Hello everyone, and welcome back to another remote sensing lecture video. And in this lecture video, we're going to build off of where we left off last time, talking about this idea of radiance and irradiance and what the remote sensor is actually measuring. And when I say that, maybe I can rephrase that a little bit. We're talking about what do the pixel values in the image actually mean. And so we're going to start off, I think, by sort of recapping briefly what we talked about last time. So we're going to have the sun here. We have the earth. In between the earth and the sun, we have this atmosphere. And then over here, we have our sensor. And so just to quickly recap what we talked about last time, right, the Earth is emitting some electromagnetic radiation. The electromagnetic radiation hits the atmosphere, and just like any other object, some portion of that energy is transmitted. So it's transmitted through the atmosphere. Some portion of it is reflected off, and that reflection will hit the sensor. The part that's transmitted through the atmosphere hits the Earth's surface. Some portion of that is reflected off the Earth's surface and hits the sensor. And then some random portion of energy from a different area gets reflected off and bounced around and scattered in the atmosphere. And it also hits the sensor. All right, so we had atmospheric reflection, surface reflection, and scattering. Right, those were the three components that hit the sensor. And we called this radiance. And what I want to do, we called this right here, this outgoing radiation, we called that radiance. And what I want to do now is I want to clarify some terms here. And the first thing I want to clarify is what's called top of atmosphere radiance. So top of atmosphere radiance is this diagram right here. Right? This is called top of atmosphere radiance, right? Because we have the atmosphere being included in the pixel value. All right, so if this is the default. If we do nothing, this is what the picture looks like. And in this case, we're including information from the surface and from the atmosphere. So we call this top of atmosphere radiance. Right, because it's the radiance that is including things from the atmosphere. This is top of atmosphere radiance. And again, this is what happens if we do nothing. If we just take the information from the sensor as is. Those pixel values represent top of atmosphere radiance. So now you might be asking to yourself, well, can we do any better? And the answer to that is most definitely we can. And there's two things we can do. The first thing that we can do, I'm going to slide this over just a little bit, is what's called atmospheric corrections, right? Is what's called atmospheric corrections. It's what's called atmospheric corrections. And I'm not going to spend too much time going into the specifics on atmospheric corrections. Suffice to say, it's a lot of computer algorithms and a lot of mathematics that model different components of the atmosphere, different components of the geometry between the sun, the sensor, and the Earth. But at the end of the day, what atmospheric corrections do, and this is a part that I would expect you to sort of understand, is that atmospheric corrections remove most atmospheric reflection right? Atmospheric reflection and scattering. And again, I don't expect you to necessarily understand specifically how to do atmospheric corrections, but just understand that this is one of the things that we can do to do better than top of atmosphere radiance. And this is just the idea that we're removing most of that atmospheric reflection and scattering. So let's draw our diagram again for what this would look like. So as always, we start with the sun. The earth. You're going to get sick of drawing this by the end of the video, but at least hopefully it will have sunk in. The atmosphere. And the sensor. Sensor. Sphere. And Earth. Right. And so we have electromagnetic radiation, same as before. But with the atmospheric corrections, we don't have the reflection coming off of the atmosphere anymore. Right? We've canceled that out through atmospheric corrections. So the only thing that we're getting is that. So just to sort of highlight what we're talking about here, let me grab a completely different color. How about white? We'll just stick with white. Oops. We'll just stick with white. And we'll just to diagram this out that this was removed by atmospheric corrections. Right? Atmospheric corrections removed this portion that was reflected off of the atmosphere. So with atmospheric corrections, what we have is we have just that portion that went through the atmosphere, hit the area on the surface, and was reflected off. So this portion that's left here now, right, this is called surface radiance. Right, surface radiance. Because atmospheric corrections dealt with the portion that was being scattered, or most of the portion that was being scattered, and most of the portion that was being reflected from the atmosphere. So once we remove those, we have just the part that's bouncing off the surface, and we call that surface radiance. So now you might be asking yourself, well, can we do any better? Right? We've dealt with this atmospheric part. Can we do any better? Or can we do anything else? And you have to realize that what we're dealing with right now, because we've done nothing else, is we're still talking about just this portion here, right? The portion that bounces off. So if we go back for a second and we look at the previous thing here, right? We're still talking about radiance, which is the outgoing, right? So we've got the outgoing radiation, right? Radiance. And with atmospheric correction, we've removed the radiance that was coming from the atmosphere, but we can do one better. And we can do that by taking into account the ear radiance, right? The amount coming in. And we call this percent reflection. Percent reflection, or you'll often see it called surface reflection. Right. So percent reflection or surface reflection. Right. And there's a really easy equation for that. Percent reflection. Right. All this is radiance. Clean up my handwriting a little bit. Right, percent reflection, all this is radiance. Right, the amount of energy going out over irradiance. Or the amount of energy coming in. So percent reflection is amount going out over amount coming in, radiance over irradiance. Now, typically, you will see this at the surface. Technically, you can get top of atmosphere reflection, where you don't do atmospheric correction, you just take the amount coming out total over the amount coming in total. So for now, what I want to do is I want to stop this video on this concept of percent reflection and this concept of atmospheric corrections. I want to stop this video. I want you to take time. I want you to think about this, because in the next video, what we're going to do is we're going to go through some examples using numbers to show you why these different things matter and where the different pieces come from. So again, if you don't understand anything about the atmospheric corrections, if you don't understand anything about percent reflection, I encourage you to pause the video, rewatch the parts you're confused about, and as always, please reach out. Thank you.